We're just going to go over some definitions and the concept of intersections from section 1.1, which is on points, lines, and planes of the geometry textbook. So if you want to follow along or need more information, you can check out that section. So the first idea I want to cover is collinear versus non-collinear. This refers to points and whether or not points live on the same line. So for example here, I have 3 points, C, A, and B, that all are on this same line here. So we can name that line a couple different ways. We could call it line CA or line AB, using any 2 points to make a line. Point D, however, over here in green, does not live on that line. It is not collinear with C, A, and B. However, if I were to ask if point D and C are collinear, the answer is yes, because you can always draw a line between any 2 points. So while D is not collinear with C, A, and B, it can be collinear with any of them individually, because I could always draw a line that connects D to C or D to A or D to B. So just checking to make sure that anytime I ask about 2 points being collinear, the answer is always yes, because you can always draw a line using just 2 points. So that's collinear and non-collinear, and we can expand that to a third dimension to talk about coplanar and non-coplanar. So coplanar refers to lines, or refers to points that live in the same plane. So for example here, this is a rectangular prism, and you can call each of the faces, right? So the top or the bottom or the sides, those would be examples of planes. And so we could say that H and E and A are coplanar. They all are on this edge here on the left, on that left side. However, we could also say that E and F and G are coplanar because they are all on the top plane. And because any 3 points determine a plane, we could say that D, F, and G are all coplanar. If we imagine there was a plane that kind of came through and cut like that, if you can imagine that's a 3-dimensional shape, then you would see that that would be a plane that would contain those 3 points. And you can do that with any 3 points, whether or not they are in the picture coplanar. You can always draw a new plane with them. So that's the extension of coplanar to the 3rd dimension. So that's exciting. And then the other thing in geometry that we often talk about is intersections. So when you have 2 geometric shapes, it's important to you that you know what to expect when they intersect. So anytime you have 2 lines, just like systems of equations in algebra class, you would expect that those intersect at a point. And so we can name that point. So if I ask you to name the intersection, I'm asking you to tell me what point is that where they intersect. Okay. Anytime that you have 2 planes that intersect, I would expect 2 planes to always intersect in a line. And so anytime that you are asked to talk about the intersection of 2 planes, your answer should be that they intersect in a line. So in this example, I have plane D, which is the vertical plane, and plane A, which is running horizontally, and lines in between them. I can't say that they just intersect in point R, because they actually intersect in this entire line right here. So I want to name that line, and you can name it multiple ways, but I chose to name it RZ. Remember, lines go on forever, indefinitely, and so by calling it a line, I'm getting the whole intersection. And that should happen anytime you're looking at 2 different planes. And then the last thing that we're talking about is a plane and a line, and if those 2 things intersect. So I visualize this as like a sheet of paper with like a pencil sticking through it. And so if you have that, you're looking at an intersection as the point. So what point on the line is also the point that's on the plane. So if we're looking again at that picture that we had earlier, we want to name that intersection of HEF, which is the top of that rectangular prism, and line GC. And if you look, there's only one point that is on line GC and also in that top plane. So it's right there, point G. Okay, so anytime you are looking at intersections, know what to look for. So if you're looking at a plane and a line, know that your answer is going to be a point. If you're looking at 2 planes, know that I expect your answer to be a line. And if you're looking at two lines, know that the intersection of those is always just 1 point. All right, so that's it for points, lines, and planes and intersections. Let me know if you guys have any questions.